Okay, hi everyone. Today we're going to be talking about semiconductor diodes. Okay, and as I shared earlier, I highly suggest that you take a screenshot uh, of every slide that comes. Okay, so that you don't miss out anything lah. But so semiconductor diodes, as we know, this is electronics. So electronics is another part of physics, okay, but it deals a lot with this type of conductor, which is called a semiconductor. Okay, now previously when we were studying electrics, we did this in our previous 2 chapters ago. Okay, we were talking about superconductors. So superconductors are conductors where at a certain critical temperature kan, the conductor is dia langsung tiada resistance. Okay, but now there's also this thing that we call semiconductors, because normal metals, okay, logam yang biasa, which is a normal conductor lah, okay, yang boleh mengalirkan arus elektrik, there's always a resistance, and we find that the resistance increases okay, with temperature. Okay, but semiconductors are interesting. Semiconductors bila kita meningkatkan dia punya suhu, the conductivity increases. Okay, dia punya resistance akan berkurang. Maksudnya, makin tinggi dia punya suhu kan, makin dia punya kemampuan untuk mengalirkan arus elektrik adalah lebih baik. So this is the interesting thing about semiconductors. And semiconductors, okay, are usually when we talk about semiconductors, we talk about all these small electronic components lah. Okay, so things that you find in your handphone, okay, all the small components, all the small components that you find in your handphone, in your TV, in our laptops these days are made up of this kind of conductor. Okay, jenis conductor inilah, okay, yang dipanggil sebagai semiconductor. Okay, so a metal is called a good conductor. Logam adalah satu pengalir elektrik yang baik. Okay, sebab dia ada banyak free electrons. Okay, that's why it's a good conductor. Insulators are very poor conductors because there are very few free electrons to move about. So this is the thing. In order for a metal, untuk satu logam atau satu bahan kan, menjadi satu conductor yang baik, you need to have enough electrons that are free. Okay, free meaning di dalam petala valence lah. Okay, this is a little bit of chemistry, so I'm going to go into this. So you know lah, okay, that any normal atom, okay, has all these petala. Okay, and we know that in a normal state, okay, for example lah, for example silicon which we're going to talk about lah. For example, silicon has 4 electron valence. Okay, means there's all these 4 electron valence kita panggil sebagai free electrons because sorry okay, it's called free electrons because dia tidak terikat dengan kestabilan. Is it kestabilan? You know lah, okay, when you talk about chemistry, right, the 8 electrons is it kestabilan octet or kestabilan octet or something like that lah. Okay, but because it is not stable, so it is free. Okay, so a metal has a lot of free electrons lah. Okay, but insulators have very few free electrons sebab kebanyakannya sudah stabil. Okay, but semiconductors are interesting because semiconductor is a material that has an electrical conductivity. Dia punya kekonduksian elektrik lah. Kemampuan dia untuk mengalirkan tenaga elektrik adalah di antara conductor dan insulator. Okay, so that's why dia panggil semiconductor, separuh conductor lah. Okay, so dia punya, it is not as good as metal, tidaklah sebaik seperti metal. Okay, and in the previous chapters we've learned that one very good conductor is copper lah. Okay, copper is a very good, that's why we use copper wires in our wiring system today. Okay, so a very good metal is copper. Okay, because copper has a lot of free electrons. So, but it's not as bad as insulator. Okay, insulator is like batu, kayu. Okay, semua ni tidak boleh mengkonduksikan tenaga elektrik. Okay, so semicon is antara these two. Not as good as metal, but not as bad as insulator. Okay, so because of that, the resistance of semiconductors is between the conductor and insulator juga. Okay, dia punya is not very resistant, which is very good because the more resistant it is, the higher the resistance, the more the heat. Okay, then you have to figure out another way to, we did that in electromagnetism lah. Okay, now two examples of semiconductors yang kita akan banyak bincangkan is silicon and germanium. Okay, and actually in our chapter we are going to mostly study silicon lah. Okay, which is why if you think about it, if you think about it, in America there's this place called Silicon Valley. Okay, Silicon Valley is not because the whole valley bukanlah satu lembah itu kan, semua diperbuat daripada silicon lah. But it is because a lot of the companies there deal with electronics. Okay, benda-benda yang sangat-sangat kecil lah. Okay, electronics, and most electronics use semiconductors. Okay, and one very good example of semiconductor is silicon. Okay, now this is another fact. At 0 Kelvin, okay, it behaves as an insulator. Semiconductors kan, bila dia tiada this one now, when there's 0 temperature, 0 Kelvin, it is totally an insulator, because like for this one, the resistance is very high at 0 Kelvin. Okay, so these are ciri-ciri semiconductor yang kamu harus tahu lah. Okay, now in a semiconductor lah, okay, in a semiconductor, I want you to get used to these two words that are going to come up a lot. Number one is called free electrons, okay, which is negatively charged, and secondly is holes. I know it's very strange to call it holes now, okay, but I will explain why it's called holes in a while. Dalam bahasa Inggeris dalam bahasa Melayu it's called lohong. Okay, yeah, I know. So like, kenapa bukan lubang kan? Kenapa mesti lohong? But oh well, what to do lah. Okay, so in Malay it's called lohong, which is holes, and we assume that the holes are positively charged. Now I'm saying this very carefully. We assume, okay, because actually kan, holes cannot move lah. Okay, yang sebenarnya bergerak di dalam satu semiconductor hanya elektron sahaja, and we know that electrons are negatively charged. But for all our discussion purposes, we need to assume that kalau ada negatif mesti ada positif. Jadi kita panggil yang positif sebagai holes, dan kita anggap yang charge untuk holes adalah positif. Okay, so let's talk a little bit more about a silicon atom. Okay, so in a silicon atom, if you notice over here, there are 4 valence electrons. Okay, 4 elektron yang di luar. Okay, and because of that, they are able to bond together with other silicon atoms untuk mencapai kestabilan octet. Okay, to reach the octet stability. I don't know why is it called in English now, but I call it kestabilan octet now. Okay, so in order to get the 8 electron valence in the outside. Sorry, somebody's audio is on. Okay, so in order to reach the octet stability, they have to share 4 other electrons with another silicon atom. Okay, therefore forming 4 covalent bonds. Okay, yeah, this is where the chemistry comes in lah. Okay, so each of the covalent bonds, okay, is formed by a pair of electrons like this. Okay, and every atom shares 1 electron with one of its neighbors. Okay, and so we find that the silicon dalam keadaan aslinya, in its natural state, okay, silicon is actually a crystal. Okay, because all the electrons are shared. Okay, share electrons, and then they form all this. In English, we call them lattices lah. Okay, so figure on here, okay, shows the outer electrons, yada yada. So because of this, no electrons are free to move about. Okay, so this is what we call a pure semiconductor at 0 Kelvin. When there is no heat, okay, when there is no heat, there is no temperature, 0 Kelvin, okay, silicon in its natural state, okay, is stable, very, very stable. Okay, because every electron is paired with another electron, and all the shells, semua petalannya sudah stabil. Okay, so point number 4, at very low temperature, pure silicon crystal is an insulator and has a very high resistance. Okay, bila suhu sangat rendah, resistance is very high. Okay, and it is an insulator because there's no free electrons. Okay, so what if I increase the temperature? Let's say I panaskan silicon. Okay, if I give a little bit of heat to silicon. So as the temperature of the silicon crystal increases, what happens is, very naturally lah, the electrons will start to vibrate a lot faster. Okay, so vibrate, 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 and then some of the electrons will break free. Okay, they'll be like, whoa, bebas. Okay, so this electron will be gone. Now, when this electron is gone, contohnya lah, okay, so here, okay, akan wujud satu hole. So we make holes, this is very strange, we make holes by heating up the silicon. Okay, so because in its natural state, it's all electrons and it's very stable. But when we heat up the silicon, okay, some of electrons will break free. And dia akan tinggal satu ruang yang kosong di sini lah, yang tidak terisi. Okay, sounds like a very sad love story lah. Okay, like somebody goes away, then oh, there's a hole in my heart. Wow. Okay, number 6. For every electron that is broken free, there is a hole, as I said, okay, in the bonding structure. Now, for our discussion purposes, we assume that the hole is a positive charge. Okay, so what will happen is, this is a very normal thing. Bila ada kekosongan kan, mesti kekosongan itu diisi. But the problem is, kekosongan itu hanya boleh diisi oleh electrons. Okay, so which electron is going to hop over? Obviously, it's this electron that is next to it. So this electron hops over here, menjadi kosong di sini, tetapi sini pula yang menjadi hole baru. Okay, and then if this is a hole that is baru, naturally the electrons, either this or this electron lah, okay, the next nearest electron will mengisi tempat ini. And then sini pula jadi lubang. When this becomes a hole, this electron goes over here. So you find that electrons are always constantly filling up the holes. Okay, and the hole is as if sepertinya lubang lohong itu, sepertinya the hole is moving. But actually the hole is not moving lah. If you think about it, I mean the hole dia wujud kerana the electrons is moving over. Okay, so one outer electron from the neighboring atom will fill the hole. At the same time, will produce a hole at Y. I will show you what Y later lah. Okay, so when the electron moves, seolah-olah the hole is moving, but actually the hole is not moving. It's just meninggalkan satu tempat yang kosong. It's like playing musical chairs, I think. Yeah, it's something like playing music. No. There's a game to describe this lah. You know, you leave one seat empty. When we were younger, we used to play this game lah. Okay, so there's always one seat empty, and then mesti ada orang yang cuba cubuk-cubuk masuk di dalam. Okay, but that's basically the situation. Whenever you increase the temperature of the semiconductor, some of the electrons will break free, menjadikan holes. Okay, so when there's a hole, so the electrons will move over. Okay, so when the electrons move over, the holes will be moving on the other side. Okay, and this is a very important characteristic of silicon, and because of that, okay, it makes silicon a good semiconductor. So it is not really a free electron, bukanlah banyak betul free electron, tapi elektron itu bergerak untuk mengisi lohong. The electrons move to fill in the holes, and this causes it to conduct electricity because the electron can move. Okay, as long as the electron is able to move, then it can conduct electricity. Okay, but because it is not totally free lah. Okay, dia bukan macam metal the electrons are totally free. Dia orang bukan mengisi lubang tau. They just have nowhere to go. Okay, but in a semiconductor, the electrons are moving untuk mengisi lubang. Okay, they are moving to fill in the hole. So because they have to move, okay, but they are not moving as freely as the metal conductors. Okay, that's why it's called a semiconductor. They can conduct electricity, but okay, it's just antara-antara sajalah. Okay, so after that super long explanation, okay, I know this one got a lot of explanations now. So after that super long explanation, if you want to just take home one thing, okay, from this part is just remember that the reason why semiconductors can conduct electricity is because the electrons are moving. The electrons are moving to fill in the holes. That's the reason why semiconductors can conduct electricity. Okay, so they are free, but they're not that free lah. Okay, they're just moving to fill in holes. Okay, but the thing is this lah. Okay, whenever we talk about semiconductors, we know that in this situation, this is actually a neutral, okay, a neutral atom, neutral silicon atom, okay, where everything is, where everything is actually about the same number, okay, the same number of holes and electrons. Okay, so how do we make, how do we make a semiconductor with, for now, I'm just going to say, how do we make a semiconductor positively charged? Or how do we make a semiconductor negatively charged? Okay, so that, because if it is positively or negatively charged, then dia punya kekonduksian elektrik akan meningkat. It will become a better conductor. How do we make a semiconductor a better conductor? Okay, it's by this process called doping. Okay, yeah, I know. Whenever you heard the words dope, it's like either drugs or like, yo man, that's dope. Okay, but I'm not really talking about that doping lah. Okay, but in the world of electronics, doping is the process of adding a certain amount of impurities. Okay, you add something into a pure semiconductor, and the thing that you add in is called a dopant. Yeah, it's called a dopant. Okay, and the purpose is to increase its electricity conductivity. Okay, remember this, in the original situation, we increase the conductivity by increasing the temperature. Okay? Increase temperature, electrons break free, holes are there, electrons have to move to fill in the holes, so other electricity conduct. Okay, but the electricity conduct is very like tiny lah. Okay, so if you want to increase the electrical conductivity, mau tambah dia punya kebolehan untuk mengkonduksikan elektrik, we have to do this process called doping. Okay, and doping is kamu tambahkan dopant, okay, or impurities to a pure semiconductor. Okay, so there are two types of semiconductors that we can produce from doping, which is number one, the N-type semiconductor. Okay, and number two is the P-type semiconductor. Okay, I prefer that you use the word N-type and P-type and try not to refer them to negative and positive lah. Although banyak perbincangan kita nanti kan akan bercakap tentang positif dan negatif. Okay, so number one, N-type semiconductor. So N-type semiconductor is we want to have more electrons, okay, than lohong. Okay, so elektron yang banyak, okay, holes yang sikit. Okay, or actually electrons more than holes. Okay, so we have more electrons than holes. When there is more electrons than holes, then the semiconductor is an N-type semiconductor. So what do we add? We add silicon atom has 4 valence electrons, which each electron is covalently. Okay, never mind, sorry. So what we add is this atom called a phosphorus atom. Okay, because phosphorus atoms have 5 valence electrons. Okay, which called pentavalent. Okay, so you think about it now, if there's 5 valence electrons, that means kalau dia bergabung dengan silicon yang 4, okay, so the 4 over here will be this one, right? So left 1 free electron. Okay, that means whatever happens, there will always be 1 extra electron for every hole. Okay, so because of that, we call this the free electrons the majority carriers. Okay, and the holes are the minority carriers. Okay, because ada lebih banyak elektron daripada proton, daripada lohong. Okay, there are more electrons than holes. Okay, so a very famous one, element that is usually added into silicon to make it N-type is phosphorus, arsenic, and antimony. These 3 you have to remember. Very commonly asked in paper 1 questions. Okay, you have to know because P-type lain lagi tau. Okay, so to menghasilkan N-type semiconductor, saya ulang to menghasilkan N-type semiconductor, you need to make sure that in the silicon there is always more, in the semiconductor, there is more electrons than holes. So to do that, you add an element which has 5 electron valence. Okay, contohnya phosphorus, arsenic, and antimony. Okay, these 3 are the most common examples and very commonly asked. Next is the P-type semiconductor. Okay, think about it. Kalau N-type semiconductor, electrons more than holes. So obviously, p-type semiconductor will be, you need to have more holes than electrons. Okay. In the p-n-type semiconductor, we want to add an element with 5 valence electrons. So in the p-type semiconductor, we don't have 5. We want to have more holes. So kita mesti memastikan bahawa 4 itu kan, bila kita tambah, dia mesti kekurangan 1 elektron. So that's why we add trivalent, 3 electron valence. Because remember, in a kestabilan octet, there's 8 phases, right? Silicon has already filled in 4. So if we add another 3, there's always going to be 1 lubang over there, which means that the lubang will always be there. Okay, so there will be more holes than electrons. So one very good example of a trivalent element is aluminium. Okay, so these are the 3 lah: boron, aluminium, and gallium. Okay, trivalent. So when you add this, what happens is you create a p-type semiconductor in which there are more holes than electrons. Means electron juga akan banyak-banyak bergerak lah. Okay, so because of this, yeah, so there's a lot of things that you need to remember lah. Okay, macam mana n-type semiconductor, macam mana p-type semiconductor. So I want you to fill in this table. Okay, I want you to take some time. I'm going to give you about 10 minutes. Actually, 5 is enough. Okay, I want you to fill in this table, copy down this table somewhere, okay, to fill in. Okay, and then you can pause the video lah. Sorry, not you. I want you to fill in this table, and then I will discuss this with you in a while. Okay, hold on. Hey. All right, everyone. So now that you have finished your table, I'm going to show you the answers. Okay, so this is what I meant lah. Okay, pure semiconductor, there's 2 that we need to discuss every time. Okay, which is silicon and germanium. The dopants material, okay, as I said, this baris kamu mesti hafal. Okay, the dopants material, the pentavalent atoms, which is 5 electron valence, is phosphorus, arsenic, antimony. Okay, APA lah. Okay, apa. Okay, di mana trivalent is BAG, BAG. Okay, boron, aluminium, and gallium. Okay, just remember 5 for apa and 3, okay, for BAG. Okay, the function of the dopant material, most of you have written it kind of there and there, okay, but if you want, you can just write the answer. The point is this, okay, to produce more electrons in the semiconductor, or this one is to produce more holes in the semiconductor. Same thing, okay, just mana satu yang lebih. Dalam N-type semiconductor, we want more electrons. Dalam P-type semiconductor, we want more holes. Okay, next. Valence electrons is 5 and 3. Most of you got this correct. Majority charge. Okay, majority charge carriers. If you did not write the word free electrons, means kamu silap. Because remember, semiconductor, the free electrons are in the outside shell. Okay, dalam petala valence. But there are actually still electrons are in the inner valence, which is not free. Okay, so this is the main point that I want to come across lah. That you need to mention that the electrons are free, because free electrons yang menyebabkan electric can be conducted, yang menyebabkan kekonduksian elektrik. Okay, electrical conductivity is because of free electrons. Okay, that's why it has to be mentioned. Okay, so please make sure that you correct your table, okay, which I'm doing, which is here lah. Okay, all right, let's go to the next part. So how do we form semiconductor diodes? Okay, so the simplest semiconductor device is a diode. Okay, diode because kenapa Shane? Okay. The simplest semiconductor device is a diode. Die kerana because the word die, okay, di over here is 2, okay, from the word duo lah. Okay, so that's a diode is 2 semiconductors. Okay, so a diode is made by joining a p-type and an n-type semiconductor. Remember, p-type got more holes, okay, and n-type got more electrons. Doesn't mean that there are no holes here and there are no electrons here. No, it just means that p-type got more holes, so that's why we call it the majority carrier. And the n-type is more electrons, which is why the electrons are the majority carrier in the n-type semiconductor. Now, the function of a diode is something that you have to memorize. A diode is a device that allows current to flow in one direction only, but in the opposite direction, it is blocked. So, for example, this is a symbol of a diode, di mana sini adalah positif, sini adalah negative. It's very easy to remember which side is positive, negative. Remember that electricity flows from positive to negative. Okay, and look at the direction of my arrow. The direction of my arrow is the same as the direction of this triangle. So it's almost impossible for you to get this symbol wrong. It's just a triangle and a line and a circle lah. Okay, so if I conduct, sorry, if I put a battery over here, okay, and the positive is connected to the positive of the anode, and the negative of the battery is connected to the negative of the cathode, sorry, the negative uh, of the cathode of the diode, okay, so we find that in this case, the electricity will flow. Okay, electricity will flow. But if let's say I buat terbalik, okay, so this is my battery, this is the positive side of the battery, this is the negative side of the battery. Now look at how it's connected. Okay, now positive, we know that electricity flows here and comes to here. But because dia menghadapi benteng ini kan, so electricity won't flow. So if I put an ammeter over here, kita akan dapati ammeter tiada bacaan. Okay, but in the other way, okay, if I put the positive here, sini negative kan. If I put an ammeter over here, okay, we find that the ammeter will have a reading because the electricity flows here, and since the electricity is the same direction as the triangle, okay, then electricity will flow. Okay, so very easy semiconductor to remember is diode. Okay, because the triangle tells us everything. Where is the positive and where is the negative? But in order for you to understand how the diode works, we need to talk about this junction. Okay, ada satu dalam bahasa Melayu, we call this simpang lah. Okay, this is called simpang PN. As I said before, semiconductor diode, the diode is a joining of the P conductor and the N-type semiconductor. Okay, bila kita gabungkan, it will become a diode. Okay, so when we gabungkan this, a PN junction is formed. Okay, ada satu simpang di sini lah. Okay, so there is this boundary over here which we call the junction. So what happens is, very naturally, as I said before, the electrons over here will hop over here lah. Okay, so when the electrons over here hop over here, sini akan terisi oleh elektron, and sini akan menjadi holes. Okay, seolah-olah, okay, seolah-olah elektron ini melompat ke sebelah dan hole ini melompat ke sebelah. Because when the electron leaves dia punya tempat kan, dia akan menjadi holes. Okay, that's why this point number 4, although not technically correct, but we write it this way lah. Holes from the P side similarly move to the N side. Okay, where they recombine with electrons. So as a result of this flow, the N side has a net positive charge and the P side has a net negative charge. Okay, now, but because ini akan sentiasa berlaku, okay, so all the electrons here akan mengisi and then all the holes will go over to this side, right? So what is going to happen is that there is going to be a lot of holes on this side and a lot of electrons on this side. Okay, so because of that, this junction akan menjadi satu layer, okay, which is called a depletion layer. Di mana over here, okay, is neutral. Okay, it is a neutral layer, which is called a depletion layer, where electricity cannot flow. That's why you need to put a battery or a source of energy to make sure that the electrons continually flow. Okay, sebab kalau ini kan, kalau kita tidak letak apa-apa, if we just kasih biar begitu kan, there will always be a depletion layer. Okay, satu, I can't remember what's depletion layer in Malay. So there will always be a depletion layer yang menyebabkan elektron tidak boleh bergerak sudah, dan lohong tidak boleh bergerak sudah ke sebelah sini. Because sudah ada depletion layer. Okay, so kalau kita bayangkan, if let's say I take this is the, yeah, sorry. Okay, so this is the positive, this is the N semiconductor, this is the P semiconductor. Bila kita kasih gabungkan for the first time, okay, elektron itu akan lompatlah ke sebelah dan menyebabkan lohong-lohong di sebelah sini. Okay, but after a while, the elektron yang lain kan tidak boleh lompat sudah, because di sini kan, sini sudah menjadi, sebelah sini sudah ada banyak lohong dan sebelah sini ada sudah banyak elektron yang sudah melompat, and because they are stuck, they cannot go anywhere else. Okay, so that's why there is that depletion layer, and that's why electrons cannot move anymore. So if we want to help the electrons, kalau kita mau bantu ini elektron yang di sebelah sini untuk melompat lagi ke sebelah, we have to give it energy, and we give it energy by giving it by sambung kepada battery. Okay, so there are two ways to sambung kita punya battery. Okay, number one is this way, which is called a forward bias. Okay, forward bias is where the P type of the diode is connected to the positive terminal of the battery. P type, sini P kan? Okay, this is the P type, this is the N type. So the P type is connected to the positive, and the N type is connected to the negative terminal of the battery. This is called a forward bias. Okay, and this is a definition. Okay, this is a definition of forward bias. What is meant by forward bias? Okay, forward bias is a situation where P type of the diode is connected to positive terminal of a battery. N type is connected to negative terminal of a battery. So please hafal ini. Okay, now the explanation is this. When the diode conducts current, sorry, bila kita sambung di sini bahkan, okay, ingat di sini adalah charge positif. Okay, and electrons are always attracted to positive charge. Okay, electrons are always attracted to positive charge. So because of that, the electrons over here yang pada asalnya kan terkandas bah. Okay, so this one is tiada current. Kita tidak supply any current. So di sini the electrons here will terkandas because they cannot move across. Okay, sebab dihalang oleh this depletion layer. But when we provide a little bit of energy, these electrons akan menerima tenaga daripada bateri ini dan mereka mampu untuk melompat ke sebelah. Okay. Sekarang kita cakap pasal lompat-lompat ni kan sangat sensitif lah. Ya, so banyak ada kata-kata pun. Okay, but that's basically it. When you give something enough energy kan, its ability to jump across becomes higher. And because of that, the depletion layer will become smaller. Okay, and itu yang menyebabkan kita punya arus boleh mengalir because the depletion layer becomes smaller. Okay, the diode conducts current because the holes from the P-type material and the electrons on the N-type material are able to cross over the junction. Okay, so because elektron akan sentiasa tertarik kepada charge positif and charge positif akan sentiasa tertarik kepada charge negatif. So the depletion layer become smaller, and that's why current can flow. Okay, because this is forward bias. Terbalik from this is reverse bias. Okay, pincang songsang. Now, so what happens is the negative saya sambung kepada P-type. This is the definition lah. Okay, the N-type is connected to the positive of the battery. The P-type is connected to the negative of the battery. Okay, and what happens is macam biasa, positif akan tertarik kepada ini dan negatif akan tertarik kepada ini. So what happens to the depletion zone? Dia akan menjadi semakin luas. Because tiada orang yang melompat ke sebelah. Semua orang tertarik pergi tepi sudah. Okay, and okay, so this reverse polarity causes a very small electrical flow. Okay, as both electrons and holes are pulled away from the junction. So when the potential difference due to the widened depletion region equals the voltage of the battery, the current will cease. Therefore, kalau saya letak satu mentol di sini macam ni, okay, dia tidak akan ini. Dia tidak akan di sana. So that's the explanation. Okay, to put it in simple terms, just remember, forward bias, P kepada positif, N kepada negatif, hidup. Okay, reverse bias, Okay, P kepada negatif, N kepada positif. Atau yang sebelah benteng ini kepada positif dan sebelah segitiga ini kepada negatif. This is reverse bias, no current. Okay, sebab kita andaikan sini adalah positif, sini adalah negatif. Okay, so negative is connected to positive. Positive is connected to negative, so no current will flow. This is very logical. Okay, kalau kita mau arus untuk mengalir, P-type mesti sambung kepada positif, N-type mesti sambung kepada negatif, and we call this forward bias. Apa ini? Sorry. Okay, we call this forward bias. Okay, forward bias, reverse bias. Okay? Okay, bear with me, guys. I'm almost done. Another 3 more slides, I think. Okay, but I want to finish this today. Do you guys want to take a 5-minute break? I give you a 5-minute break. Let me pause the recording first. Okay, so let's continue to this last part. So we have seen how a diode works. Okay, I hope that you can understand the super long explanation, which I feel that I don't know how many times I repeat lah. Okay, but basically you just have to know how macam mana depletion layer terbentuk, and then how the depletion layer dijadikan lebih nipis atau lebih tebal. Okay, lebih nipis kerana forward bias, lebih tebal kerana reverse bias. Okay, so what are the uses of a semiconductor diode? Okay, kegunaan utama dalam semiconductor diode is this one, sebagai rectifier. Okay, so dalam bahasa Melayu is rectifikasi lah, but whatever lah. Okay, so fungsi utama diode adalah sebagai rectifier. Now, a rectifier is an electrical device that converts alternating current to direct current. Now, ini kita sudah belajar di bab yang lepas. So, this is the bentuk alternating current. Okay, ada positif, ada negatif. Dan fungsi diode adalah untuk menjadikan dia mengalir dengan satu arah sahaja, which is direct current. Okay. Now, there are 2 types of rectification. One is a half-wave rectification. One is a full-wave rectification. Okay. Half-wave rectification is a process where only half of every cycle of an alternating current is made to flow. Half sebab sini positif kan? Tengok, sebelah sini adalah positif, dan sebelah sini pun positif. Okay, so ini tetap mengalir. Pada negative part, dia hanya akan menjadi kosong. Okay, now how this happens is, okay, let's say this is positive and this is negative. So arus mengalir di sini. Arus mengalir lah bahkan, sebab bila sini positif, sini negatif, this is forward bias. Okay, so forward bias, arus akan mengalir. But remember, alternating current kan, dia punya positif negatif akan sentiasa bertukar. So let's say this is negative, this is positive. Arus mengalir di sini, tetapi disebabkan ini adalah sambungan reverse bias. So current will not flow. And that's what happens over here. Sini adalah reverse bias. So forward bias, reverse bias. Forward bias, reverse bias. So apa yang kita akan lihat di sini kalau saya pasang satu mentol, sini dia akan hidup, sini dia akan mati. Hidup, mati, hidup, mati, hidup, mati, hidup, mati. So that's why we call this a half-wave rectification. Sebab hanya separuh saja, okay, separuh saja yang dibenarkan untuk mengalir. Only half can be rectified. Okay, so that's basically the explanation of half-wave lah. The other type of rectification is called full-wave rectification. Now, this circuit, okay, this litar ini memang disusun macam ni. Okay, tengok half-wave. Half-wave very easy. Sangat senang half-wave. Okay, just one diode. But full-wave rectification memerlukan sampai 4 diode yang disusun macam ini. Okay, so a process where both halves of every cycle of an alternating current is made to flow in the same direction. So yang positif itu, okay, kekal positif di sini. But the negative part, kalau half wave rectification kan, dia akan jadi kosong bahkan. Tapi full wave, dia akan tetap mengalir dalam arah yang sama. Okay, let me prove this to you. So let's say this is positive and this is negative. Okay, so arus mengalir di sini. Okay, bila dia sampai di sini, dia akan mengalir di sini. Okay, ya. Yeah. Okay, dia akan sampai di sini and then it will flow over here. Okay, over here, sini, sini, and then sini. Okay, so tetap mengalir dalam satu arah. So here is positive, here is negative. Begitu. Okay, I'm going to change color. I'm going to change color to show you kalau dia terbalik. Sorry. You know, every year I teach this kan, every year saya mesti salah di bahagian ni. Kau tengok ah. Okay, so let's say this is negative and this is positive. We're talking about this side already lah. Okay, so sini dia mengalir. Okay, mengalir. Obviously, it cannot flow over here because dia dihalang oleh benteng ini. So it will flow here. Okay, flow over here. Hey, siapa yang melukis ini? Ish. Okay, flow over here kan. Dia tidak dapat mengalir di sini sebab dia dihalang oleh benteng ni. So it will flow here. Okay, so it will be positive here again. Hello, stop. Stop annotating, please. Okay. Then, flow over here from negative. Sampai di sini. How? It will flow here. Okay. And then go back to here. Negative. Okay. Now, if you don't get this, you can always rewind this video when I put it on YouTube and show lah. So because of that, we find that, okay, in both instances, the positive and the negative is the same place. Okay, that's why dia akan terhasil one direction only. Okay, but as I said lah, if you don't get it, okay, if you don't really get it, doesn't matter. Okay, all you have to know is just know how the susunan of the diode is. Okay, this is a very important circuit to remember. Okay, actually the explanation is here lah. Okay, A, P, T, U, R, and then B. Dan kalau second half dia akan pergi B, S to T, U, and then Q to A. Okay, but because of the susunan diode begini bahkan, okay, it will cause this AC current to become a DC current di mana dia akan sentiasa hidup. Okay, as opposed to half wave, which is hidup mati, hidup mati. Okay, this will be always hidup, 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 because there's always constant current flowing. Okay, so the two main purposes of a diode. Okay, kegunaan diode utama adalah half wave rectification and full wave rectification. Okay, now this is a problem. Okay, this is a problem because this is a worse problem lah. So dia hidup mati, hidup mati. But this one is also a problem sebab dia terang malap, terang malap. Dia akan menyala, it will always be lighted, but it will become brighter, darker, brighter, darker, brighter, darker. Okay, which is actually not good for our eyes lah. Okay, so how do we make this? How do we make this darker and brighter? Not so apparent lah. Okay, what we do is we add a capacitor. Okay, so this is a capacitor. Okay, the symbol for capacitor looks like a battery. Okay, this is a symbol for battery, and this is a symbol for capacitor. Okay, sama panjang. Okay, so what happens to the capacitor is actually the capacitor dia punya fungsi adalah untuk menyimpan cas. So when the current passes through the resistor and the capacitor is charged. When there is no current flowing atau when the current dia macam semakin merendahkan, the capacitor okay, so the capacitor will discharge. Okay, when there is no current passing through the resistor and the capacitor will discharge and the energy will be used to memasang this lampu over here. Let's say saya pasang lampu lah. Okay, so we know that kalau kita kasih biar je these electrons, the electricity to flow through the diode, dia punya current kan akan begini bah. Okay, akan berterang, bergelap, berterang, bergelap. So the function of the capacitor is to make sure that bahagian sini kan, okay, bahagian sini dia akan memberikan elektrik kepada mentol ini supaya dia akan sentiasa kekal terang. Okay. Berbanding dengan yang ini kan, dia terang malap, dia menyala. Okay, the light bulb is actually lit up. Okay, dia menyala. Cuma dia punya nyalaan itu terang, malap, terang, malap, terang, malap. Okay, dia bukan on off. This is on off. Okay, this is on off, on off, on off. Half wave rectification. Full wave rectification is always on, but bright, dark, bright, dark, bright, dark, which is not good because akan menyebabkan kita punya mental rosak juga. So to fix this problem, we add a capacitor. Okay, so that when the current is going lesser, the capacitor will provide the current. Dia macam power bank lah. Yeah, the capacitor basically works like a power bank. It collects the charge and then bila diperlukan kan, dia akan memberikan charge. Supaya kita punya mental, dia akan sentiasa ada arus mengalir. There will always be current flowing in the mental, in the light bulb, which is more constant. Okay, berbanding dengan ini yang kurang constant. Okay, yeah. So that's basically this entire subtopic in one class lah. Okay, so let me just basically give you an overview. Number one, you need to know what is a semiconductor, okay, and the two pure semiconductors that we study. Okay, number two, you need to know what is free electrons and holes, okay, and remember that the word electrons must have the word free in front when you're talking about semiconductors. Okay, secondly, you need to know how the pure semiconductor punya characteristic lah. How is it that there are holes and electrons that are free? Okay, third, next you need to know what is the meaning of doping and the two types of doping. Okay, one is the doping to produce N-type semiconductor. The second one is the doping to produce P-type semiconductor. Perbezaan antara N-type dan P-type semiconductor juga harus kamu tahu. After that, you need to know how the PN junction is formed, what is the function of a diode, and how do we increase and decrease the depletion layer. Okay, because bila depletion layer berkurang, arus akan mengalir. So we call this forward bias. Bila depletion zone atau depletion layer ni menebal, okay, when it becomes bigger, you become reverse bias and no current will flow. Okay, and then of course, lastly, you need to know the function of a diode. Okay, the main function of a diode is as a rectifier. Okay, two types of rectification, half wave rectification, di mana the AC current will become DC current, but because it's only one diode, so the bahagian negative will become zero. And lastly, full wave rectification, where the negative will become positive. Okay, through this super complicated circuit. Okay, and lastly, how do we improve full wave rectification? Is by adding a capacitor. Okay, and the function of the capacitor is to smoothen the current untuk melicinkan, okay, output current supaya dia tidak terang malap. Okay, dia bukan on off, terang dan malap. Okay, just bright and not so bright, bright and not so bright. We want it to be always bright, so we add a capacitor in there. Okay, so after this, I'm going to give you your assignment for this week in our WhatsApp group lah. Okay, then I will let you know. So I hope that this has been helpful. Yeah, I know it's pretty long. Sorry for it very long because I want to finish this subtopic as soon as I can.